Hello, everybody out there in YouTube land. Good times for all, and Zachary Zabala here if you prefer. Today, I am talking electricity with LCKing. Lucas, how you doing today, man?
Yeah, I'm good, mate.
How's the weather treating you on the outer skirts of the plane?
Yeah, it's been pretty cool, actually. So, surprisingly cool.
Yeah, this is my first time in this area, so I really can't say. But it's warm here for me.
Yeah.
Weather treating you on the outer skirts of the... Whoa, sorry about that.
Oh, well, that's working.
So thank you all for joining us here. We're going to be talking a little bit of electricity today, and I like to start these off with a little video, just a real short clip. It's about a minute long, and it's Walter Lewin, the former MIT physics professor of 4 decades. And this is him explaining to his class for the very first time in his 802 electricity and magnetism course what exactly electricity is and how much it actually affects the world around us in so many different ways. So here you go, Walter Lewin.
Electricity and magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, televisions, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that.
Sorry about that. I'm sitting here talking into a muted microphone. So that was Walter Lewin. That quote you saw there at the end, if you only know the name, you know nothing. I think that's one of his pokes at all these so-called physicists and professors who are out there teaching. And yeah, they know all the equations, but they don't comprehend how it all works. So he's saying, if you only know the name of all these different, scientific things, then you really don't know anything. And that's one of my favorites. So today we're going to be doing a little bit of talking about how electricity interacts in nature. That's where most of our discussions, I'm thinking, we're going to try to keep them somewhat, nature-based. We might get into a little bit more advanced stuff later on down the road. But I really want to nail home how electricity, at least the stuff we can measure here around us in nature, is controlling our world in so many ways. Anything to add to that, Lucas?
No, let's keep going in. Yep.
All righty. Yeah, I have a quick video I'd like to show. There's been some discussions on, there's liquid, there's solids, and there's gas. And we have liquids being manipulated by magnetism and electricity. But it's really hard to show gases reacting to a magnet. I've been thinking about it, and how do you turn a gas into a color without, adding something to it? I don't know.
Yeah.
It's difficult. But with electricity absolutely affects gases. There's a thing called ionic wind. If you are, St. Elmo's fire would be one of the natural phenomena you might see in nature. People have claimed, to see like a green looking Christmas tree or blue, like of electricity, maybe on a mountaintop or on something. And it'll actually blow the gas above it. It will actually move that gas. Have you ever heard of ionic wind?
Yeah, I've heard of ionic wind. I've heard of those St. Elmo's fire things as well, especially out on ships.
Mm-hmm.
Yeah, so that sort of
Yeah, the ship is the highest thing around for miles when it's out on the water.
Yeah.
And all that electricity will try to be getting up there to that. Have you ever heard of the guys Cryosan here on YouTube?
I don't think so. No.
They're these amazing Russian guys. They're young. They might be in their 30s or so, somewhere around there. And sorry about that. They play with a lot of electricity, like very, very large amounts of electricity. They're pretty crazy, if you ask me. I might try to do some of the stuff they do, but I don't know. A million volts in your body, you got to be real careful when you're playing with that kind of electricity.
Yeah,
Now,
for sure.
I've done the ionic wind thing. I think we showed that last weekend, just with a little candle and the nail blowing it. Well, I wanted to show you one that was a little more viewable, a little more like, okay, that's definitely ionic wind. So I found this one. I'm not going to share the audio. It's but these are the guys right here, Cryosan English. And they've been doing this for a while. This one is almost 3 years old now when they were doing this. So they have a little bit of electronic equipment. There he is sitting up on a bucket. Now all that is standing up because he has 1 million volts of static electricity around him. He starts getting very brave and getting close to the ground. But the part I really wanted you to see is right here. This is ionic wind. He's sitting there just blowing out the candles.
Wow.
Now watch this. All the candles are up and he just points at them. The gases, between him and the candles are so charged that they start moving because they're, it's so positive where he is. And it's trying to dissipate that as quickly as possible. And it starts creating wind to where, he's a good what? I would say 18 inches maybe from there when he's doing this.
Yep.
And yeah, now this is a lot of electricity, but even a very small amount of electricity like I was using, you could show that electricity definitely has an effect on gases. Just an electric potential difference between the gases will cause them to start moving. And I just wanted to make that super clear right there. That is, yeah. So if you have an electric potential gradient and you have, especially different densities of gases. The denser the gas, this is one of those laws of electricity, the denser the object, the more electric potential it can hold. Does that make sense? Yeah, so when something's up in the air, it is starting to gather electricity. And if it's denser than the other material around it, it can become more electrically charged. It can gain more potential. And that's why denser objects move along the vector towards the negative. There's a lot of talk about, semantics in the definitions we're, trying to lay forth in the future. And I hear this term relative, and I'm not sure, this is my take on what I heard. Relative means that if you're laying on your side or doing a handstand, up would be towards the ground now if you're doing a handstand, and down would be towards the sky. That makes
which is ridiculous, isn't it?
Yeah, I mean, that's science is a study of nature, not so much the study of nature by which direction I'm laying. If you want to get technical, we can just say that, gravity, if you want to call it that, has a vector, and it is absolute. There's a positive above, a negative below. Everything goes towards the negative.
Mm-hmm.
Whether that's causing it or not, that's the direction. There is a vector. It means it has a direction and a magnitude of energy. There's a magnitude behind it, and it has a certain direction. And
the other thing we probably should talk about, just in relation to that video before, is the difference between static electricity and current electricity. So what we were looking at before with those guys was static electricity. And the most significant difference between static and current electricity is that static electricity, the charges are at rest and they are accumulating on the surface of an insulator.
mm-hmm.
Whereas in current electricity, they say the electrons are moving inside. So one's on the outside and one's on the inside. So just to sort of clarify what these two sort of modes of operation, in a sense. We'll get into that a bit later as well.
Yeah, absolutely. But yeah, that is a great point. There is such a big difference. And I think it's Walter Lewin's third class lecture where he goes into electrostatic potential and electric potential.
Yeah.
And it took me a while. I had to watch that. Well, I've watched all of them probably 10 times, but that one especially, I went back and watched over and over and over again. So don't be upset if, especially if you're not getting that off the little information you're getting from us right now. Well,
the static electricity is basically, you can just think of it accumulating on the outside of something.
mm-hmm.
So
yeah, that's a good way to look at it.
Yeah. Whereas current or electricity traveling through something, say a wire or something like that, that's your current electricity. In a sense, it's going internal.
Absolutely. Yeah. So yeah, that was one of my things, though. I want to show that the electricity in the atmosphere itself, even the static electricity in the atmosphere, because it has a potential gradient. As it goes up, it gets higher. You put objects up into it, there will be that force applied because there's more positive above the object. If the object is positively charged, it's going to push away from that. And there's a negative below that object. So that positive is going to flow towards that negative along that vector line.
Yeah.
Now, density and buoyancy, of course, are so much stronger than this force. This is a very weak force that is just giving it that nudge to tell the denser object which way to go.
And this gets into what we were talking about sort of offline about how, our atmosphere and the amount of water and things like that actually acts like a insulator in a sense as well. So there's other things happening that may actually reduce that atmospheric charge in
Absolutely.
a sense, or accumulate it.
Yeah. When I was out in the desert, oh, sorry, go ahead.
Yeah, go.
I was just going to say, when I was out there in the desert, and I even had my Van de Graaff when I was out in Colorado, and it's so much drier out there. I was getting so much more discharge in big charges, bigger than I'd gotten in Indiana, where it was always much more humid. And now down here, I can't get barely much of a charge at all. It's weird.
Yeah, exactly. And that's what when I showed last week with Mr. Piggott, what he was doing was drying the air out before it, in his static electricity machine. So he was having really dry air, and that's how he was able to increase that voltage.
Man. Yeah, that's why, Tesla moved out there to Colorado. He tried it in New York, and I think it may have been one of these things right now that we're talking about, the humidity in the air. He may have realized that, oh, dang, I can't have that.
Yeah, well, yeah, could be, definitely. So yeah, the water in the air seems to make a lot of difference too, and this is where we get into we were talking about lightning and things like that, and how that actually could possibly be working. And what we were looking at was the difference between distilled water and salt water. So salt water is an electrolyte. That means it can carry charge through it, whereas distilled water is an insulator. And there is some YouTube video clips where people are actually plugging in lights and things like that in distilled water, and it doesn't actually, they don't get electrocuted because it acts as an insulator. Now, what we're saying with static electricity is that it actually accumulates on the outside of an insulator. So when we're looking at, say, cloud formation or this, as the water gets distilled by the sun, then you've got basically distilled water. So charge can actually start to accumulate around this distilled water, and then basically you're building up charge, and that's possibly one way that we see lightning and things like that. It's that accumulation of charge electricity around distilled water.
Yeah, absolutely. And the rain, a lot of it is somewhat distilled. There's some particulates falling in there with it, but
yeah, exactly. But in general, it's pretty clean.
Yeah. It's a lot cleaner than the water that's coming out of the ground.
Yeah, definitely. And then I was looking at some other things about how they were saying that certain sulfurs help accumulate water, cloud formation and things like that. So again, whenever you look at these stuff, you nearly always see the same principles, or this, the same three elements. You have the salts, you have the sulfur, and a galvanic sort of, these galvanic properties again sort of show up everywhere.
Yeah, I'm ignorant when it comes to this stuff. I really need to dive into your videos like I've delved into Walter Lewin's. Yeah, the chemical reactions, I just haven't. That's why I love having you here, man. This is great.
Yeah.
I can bounce things off you, and you just, yeah. So I have a quick video I want to show about water falling and what happens to it when it does fall. We are going to go take a look at Walter Lewin again. He's one of my favorite teachers. I really enjoy his work. The videos, he's still on YouTube making videos.
Oh, is he?
Yeah. You
should hit him up, Zach. Have a talk.
I was thinking about it. I mean, I've sent him a bunch of thank yous, just telling him, you're the man. You've taught me so much, and I've never even met you, more than any teacher I've ever met. Yeah.
We'll get him to come on the show.
Yeah, that would be pretty cool.
He can school us. Yeah.
Let me see. What did I do with this video? I know I have it. Okay, I'm just going to look on YouTube real quick. Sorry, folks. But pretty much the video will be showing that as water is falling, it's creating a static charge. As the water is falling, it even starts, as the charge builds up, it affects the water, and the water starts acting differently. 802 electricity. Sorry,
Yeah, you're right.
there we go.
Yeah, so what I was saying before, you can basically, in a sense, think about the water as the insulator when it's distilled, so it's accumulating on the outside, and then the sort of reverse is happening in a sense to salt water, where current can actually, or electricity can actually flow through it. So I'll just sort of reiterate that distinction. Oh, you got him?
Yeah, I found it. Here we go. I think I'll let him even speak a little bit, see what he has to say about this. He's going to just explain his apparatus that he has sitting here.
An I3, you see. I don't even start off with an I3. It's not there, it comes in later. So the choice is
I
yours.
love these.
Now I want to entertain you for the last 6 minutes with something amazing, something that is truly amazing. And it is a form of a battery that is mind-boggling. And the battery is right here on my left, on your right. It is a battery that produces an enormous potential difference. 10, 20 kilovolts. You see a schematic here on the transparency. You have a bucket of water here on the top, and you have glass, and the bucket of water is hiding behind here. Not that because we hide it from you, but that's the best place to be. And you see plastic tubing coming down, and the water can run out on the right, and it can run out on the left. It runs out here. There is some paint can, no top and no bottom. And you see this paint can here. It's completely open. There's a letter A. And there's another paint can on the right. There's a letter B. It's a conducting can. This is also a conducting can. And this water runs into another conducting trash can. And this water also runs into a conducting trash can. And now comes a key point. That this conductor here, A, is connected through a conducting wire with C, and the conductor B, the paint can, is connected with a conducting wire to this trash can D. You let the water run for a while, and you will see between these 2 points here, sparks. Even when the points are as far apart as, say, 5 millimeters, when you're talking about at least the potential difference of something like 15,000 volts, you will see the sparks. And you wait, see another spark. And you wait, and you see another spark. So this is a power supply. And there must be energy coming from somewhere. And so problem 4.1, which you haven't seen yet on your fourth assignment, is asking you how this works. I will demonstrate it today, and I will come back to it later. The way it works is actually quite subtle, but I want you to think about it. It's a remarkable battery, a remarkable power supply. As the water starts running, I want to draw your attention to the fact that you can almost anticipate when the spark occurs, because the water at the very last is beginning to spread. It doesn't come out anymore just like a narrow cylinder, but it begins to spread. And then comes the spark. And then it goes back to running normally, and then slowly in time it will spread, and then comes the spark. So let us get it going. You have some light here. Marcos and Bill spent a lot of time getting this going. Marcos, do I have all my lights the way you want them? You're happy with that. There you see the two balls, which are really here. And let's first look at the sparks. So I will start the water running now. Let's just be patient a little bit. And let's see where we see in spark. Did you see one? Did you see the spark? Oh, you were not looking. Man, you're paying for this. Look at the two balls. Give it some time again. Have to charge up. I can already anticipate it's coming up. It's coming up. Yeah! Did you see it? 10, 15,000 volts. Let's give it a little bit more time and then we'll take a look at the water flow, which I can see. I'm close. But we can make you see the water flow. Look again. It's coming up. Did you see it? I could see it coming up. I can make you listen by having my microphone near the water, and you can hear this water running. Familiar sound to all of us. And now the sound changes. You hear change, and there's a spark. Once more. It's running. Spreading. Coming up. Yeah! Amazing, isn't it? I can make you see this.
All right. So what did you think about that?
Yeah, well, it just reminds me of like, how clouds and the thunderstorms sort of act,
Mm-hmm.
You get that sort of lightning and thunder and then boom, you get all this rain. So yeah, it's interesting how there's definitely a connection there for sure.
Well, yeah. Did you hear when he said it was like a battery? I thought of you. When I went back and watched this video, I was like, oh, Lucas is going to love this.
Yeah, that's sweet.
Because they say, sometimes it's positively charged and sometimes it's negatively charged, the cloud system.
Yeah, okay. I didn't know that. I only know the sort of the highs and lows, those low pressure systems. So there's definitely a different charge happening there, just with that.
And it also made me think, what if while rain is up in the cloud, right before it turns to water, what if it is kind of like an almost instant thing and water just starts pouring out of the cloud? Have you ever seen the rain fall from a distance? It looks like real thick rain falling, and then all of a sudden it starts getting lighter and lighter as it gets to the ground. When you're watching a thunderstorm off in the distance, you can tell where it's raining.
Oh yeah, it looks like a big sheet. Like around here it's fairly flat, so we can see, a fair distance, and yeah, you can just basically see the clouds, and then out the back of it, it's like a sheet coming down.
It's making me wonder, what if water doesn't drip out of the cloud? What if water is poured out like we saw there, and then once the static electricity builds up, it starts separating the water? By the time it gets to the ground, it's in small droplets.
Yeah, it's separating as it goes down, so it's charging up as well as it goes down. Do you reckon?
Mm-hmm.
Yeah, that makes sense. And it's interesting. Maybe there's there is a connection where that where the lightning hits the ground and then it's losing all its charge, and then it just drops all the water again.
Yeah.
Just like that showed. It's definitely something. Yeah. Definitely something to think about.
And I love how I love the way he teaches and how he explains things. And not only visual, but he's like, listen to it. Use your ears and just listen to how it starts falling differently. That steady stream, and then to where you couldn't even really hear it. It was pittering so much.
And how many volts did you say? It was in the tens of thousands, was it?
About 15,000 at 5 millimeters.
Oh, okay. Yeah, that's
It's a nice
Huge,
little,
isn't it?
yeah, yeah. That's a big chunk of electricity coming through.
Well, they say the lightning is what, in the millions of volts.
Yeah. Well, according to what was it? Back to the Future, 1.21 gigawatts.
Yeah. There's
So I'm
lots
not
of
sure. Yeah,
yeah.
but no, I'm not
Goes
exactly
88 miles
sure.
per hour for sure.
I do know, and Walter Lewin, he was talking about this in one of his videos. I'll see if I can't find this one. I've been looking for it, but he talks about lightning, and when lightning takes place and you can see it, that charge has displaced back and forth to the ground at least 6 to 7 times.
Yeah, right. So, yeah, well, I've heard Ben say it basically comes from the earth first to open up sort of like a pathway, and then it comes back
Hmm.
down. So that's interesting, isn't it? Because
Yeah, we can't see it. It's going so fast that we can't register it with our minds. It has to be at least 6, or I forget how many, depending on how far away the storm is or whatnot. But yeah, 6 to 7 strikes before it becomes visual to us.
wow.
Yeah. Which makes me think, is there lightning striking all the time, all around us, just one strike at a time? And we can't see it. I remember seeing a video. I meant to ask Bob about it, but it was an infrared in super slow motion, and it was showing all these what looked like lightning strikes just everywhere, just striking down all over the place.
Oh,
And
wow.
yeah, so is that happening everywhere all the time, and we just don't see it because our eyes aren't fast enough to perceive this light?
Mm.
I don't
I
know.
always remember the what Conspiracies Are Us. He done a video where these guys back in the day would have some, these older funny outfits, or they'll be carrying umbrellas with, straps, or
Hmm.
large hats. So, you know, has the charge changed or been changed in the past? Was there more charge in the past and things like that? So, yeah, it was just interesting. It's worth having a look at his video. I forget what it's called, but yeah, he's talking about all these clothing back in the day where they basically have stuff on their clothes that would help dissipate charge.
It
So,
makes you wonder, like what's going on now. I driving today. It was really weird. My GPS has been pretty good. It's been, you know, pretty accurate the last couple of years. And today, for some reason, until I got about 20 minutes to where I was going, it thought I was in a field 100 yards off to the right of every road I was on. It
yeah,
could
right.
not, yeah, it could not pick up my location correctly for some reason. And it was better when I came back home, when I came through it again, but there was a time in there that GPS thought I was driving through people's houses and stuff.
Yeah, okay. Yeah, look, this season for me, I've been here about nearly 10 years, and this is the most odd season ever. Usually it's dry, it's hot, but we've been, like now, I'm still wearing jumper, and it's nearly Christmas time. It's supposed to be burning hot,
Nearly 10 years. And this is... Sorry.
Yeah, that's all right. But we've had sort of years where it's flooded and things like that, and it's still been pretty warm. But yeah, the weather's really, really different. So I'm not sure what's happening.
Yeah, I wish that's one thing that it really bothers me is almost all of the information I have about the electric field and how strong it is and the potential gain and all this stuff. I haven't verified it for myself yet. I have pulled electricity out of the air, I've been able to do that. So I know there's some up there, but I haven't been able to do it at different altitudes and
You did it with a wire, didn't you? So you're
yeah.
not talking about huge amounts of surface area.
No,
either.
not at all. It was a very small amount of, but it was a current that I was just drawing from the air, like
Yeah.
0.02 volts or something tiny, a very small amount of electricity. But when you have a small bit up there, that's all the potential that it has, that density right there, that the size of it, it can only hold so much potential energy before it starts dissipating off or going down into the ground.
Yeah. 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 We definitely need decent measurements of all this stuff to actually get a,
Yeah,
so people
firm
see,
grasp.
yeah, how much is actually around us, and yeah, the potential differences between each. And but we're trying to cite a few examples at least of things that could be happening, and it seems reasonable that there's the higher up we go, the more there is. So
Yeah, that's the way electricity works until it hits the capacitor, whatever is, giving off this charge. And I have no idea what that is.
and there's there's other people doing sort of, I've spoken about them a little bit, even getting charges and electricity through in the ground itself. So they're called earth batteries, and they'll basically set up. I've seen ones where they add acids to the ground and have something. So basically creating an in-ground battery, but there is energies flowing through the earth as well. So, and that could be to do with there's also underground water that's flowing. So, and like you showed with water flowing, you have that charge. So there's also that.
Yeah, wow, I never even took that into consideration, all the underground water moving around and the electric current that's creating.
Yeah, it's interesting. Like where I live, you can see where the rain will follow the trees as well, and it will follow sort of certain paths that it wants to go down, and we'll get some of it. But you go 10 k's south of us, and you'll get tons more water, basically. So, is it following underground sort of things as well? Is there underground water that it wants to follow as well, or are the trees responding to the clouds? I've heard that too, where the trees can sometimes seed the clouds, which is interesting as well.
Well, yeah, they're putting off a whole lot of, their gases.
Yeah.
And I'm not sure. I've never measured it. I don't know if CO2 is coming out of the tree or not. I don't know. There's so much of this stuff that we're told, and I'd like to take people's words on it and things like that, but I don't know.
The other thing I was looking at was what's called a spring tide. And we can probably go over that a little bit, but they're just basically really big tides, and they were saying it depends on where the moon is and things like that. And obviously, I don't think it's just the moon. I think the sun has, and all the planets seem to have a correspondence to the tides. But in general, if we're working off, what I say about the galvanic model sort of thing, well, the moon is extremely high voltage and somewhat directional towards the sun. And yeah, so it's just interesting to see when you have these full moons, you're getting these what they call a spring tide. So people can have a look at that as well.
Yeah, I'm going to have to look into that. This topic is so broad. There's, like we saw at the beginning of the video, electricity. It just happens when things are moving around. Usually there's some type of electricity transfer going on. It's just part of nature. we're in a bowl of electricity pretty much, or a box of electricity, if you'd like.
Yep, exactly. And as
Now,
soon as you have these elements, you know, the same sort of elements, you have the salt water, you know, the salts, the sulfurs and things like that, then you're getting these reactions. So it's just as far as I can see, it's the galvanic cell type layout and the elements involved in it is fractal. So that's why when we sort of overlay it, we can see the same correspondence happening. Yeah.
did you get a chance to look at that Alchemy book I shared with you?
Yeah, I had a quick read of it, not very much though.
Alrighty, I wanted to just show you one part of it. Here we go. Oh, I'm starting to get this stuff. So it's Real Alchemy, a Primer of Practical Alchemy by Robert Allen Bartlett. Now this guy, he teaches at a school of alchemy up in Washington State. I really enjoy the way he looks at alchemy. You know, he's one of the people that says it's not about turning, you know, any type of metal into gold. It's not about trying to live forever. It's more of a spiritual journey to cleanse your soul and your body to get it as pure as possible. And I really enjoy just his, I mean, this is a great read. Just the introduction. I always get a tear in my eye in one of the parts. And he goes through the history of alchemy, but at the end he shows you so many of his resources where he went from, which I went looking through alchemy stuff a week ago, and so much of it was that they didn't have any like alchemists that they went to put in their notes saying like, I got this from this book, or I got this from this book. So he's gone back and read all of the work of the older alchemists, and he kind of even shares some of their stories from way back when in here. It's a great read, even if you're not interested in
Just go
all
back
this
there.
stuff.
You see that layout?
Right here.
No, just down a bit where there's
Oh,
that diagram. So that diagram is a lot of, well, I saw a lot of correspondence to the galvanic cell right there, where you have the celestial salt and the celestial niter, which is basically your sodium and your potassium. So celestial just means sky. So they're talking about the salts in the sky. And then you have the salt down the bottom. You have the three elements there, and that's the salt water, or the salt, and then the mercury can be thought of as the electrolyte, and then the sulfur. So they're your main three elements. And when you do this sort of research, you end up finding you'll come to these three things pretty much again and again and again. It's just over and over, especially the salts and the sulfur. The mercury is somewhat finicky because it is the nature of Mercury or Hermes is sort of this twin idea as well. So it's a mixture.
like your connection to your soul, almost.
It's a connection between two polarities. So it's actually say the positive and the negative coming together, and that would be in a sense neutral, but also it's a connection between the salt and the sulfur. And what also is interesting is you could also, I've thought about it like this, but it could be incorrect, but there's a gradient between the salt and the sulfur as well. So, and mercury has always been this sort of in the middle between
like the neutral.
Yeah, it's
now,
where the salt and the sulfur join, and one you can think of earth elements, one you can think of air, sort of fire, that sort of thing. So it is actually it's really worth just contemplating this chart just on its own and what it's trying to say to you. It's a fascinating sort of layout.
Now, do you see these 4 right here? The earth, water, air, fire.
Yep.
Now, the way he's putting it, at least, earth does not mean earth. Doesn't mean trees or ground or animals or rocks or anything like that. The water doesn't mean water, air doesn't mean air, and fire doesn't mean fire. All 4 of these are your 4 forces that we talk about now. And this is the material world right here.
Yeah, that makes sense.
These 4 right here do different things to your material to make different things. All material has all 4 of these in it. This is your strong nuclear force, your weak nuclear force, your electromagnetic or your magnetic force, and then earth, they call it gravity.
Yeah. And I've always thought of those 4 as the states of matter. So the states at those, if you look at those 3 down the bottom, well, you could say the salt, mercury, and sulfur are, like you say, the elemental actual things, whereas the earth, water, air, and fire are actually the states. So earth is solid, water is liquid, air is gas, and fire is plasma. So they're the states that they operate in as well.
Yeah.
And I've overlaid it for the galvanic cell as well. So you can have the earth is the salt bridge, the water is the electrolyte, the air is the moon, and the fire is the sun. So there's that sort of correlation too. But it is a really, really nice schematic, and it is I think it can be applied in more ways than we probably know how to.
Yeah, exactly. Yeah. Here's just a real quick, just what he thinks about it. These elements of the 4 elements, water, earth, air, have nothing to do with the material bodies of the same name. They are, in fact, energetic states, each in their own unique characteristics. As early as 500 BC, blah, 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 the ancients called these the 4 elements and recognized them as essential qualities by which nature operates and is formed. The element of fire relates to qualities of radiance, expansion, warmth, and light, anciently known as the hot and dry properties. Superconscious mind. Okay, I just want to get to a part. And then it goes and tells you about what the other ones are. Modern science agrees that there are 4 fundamental forces governing the activity of everything in our universe. And though they call them strong nuclear force, weak nuclear force, electromagnetic force, and gravitational force, they are related to the ancient element quantities of fire, water, and air, and earth, respectively.
Well, it seems to me modern science can't get away from this stuff. It always seems to be represented either out of context or whatever, but it's there underpinning the whole lot.
Yeah, a lot has been added to it, the spiritual side of it, but there is an actual, scientific way that they looked at these.
And there was a whole medical side about this as well, where they would look at the constitution of the body in that 4 element schematic as well. So, and treat the body using that.
Now, the one picture that I saw that I was like, whoa, Lucas has to see this one. He's just got to see this one. Let me see. There's not too many pictures in this book either, and I think they're all drawings. It gives you, some zodiac signs. Do you see anything out of place here?
Oh, I'd have to.
Yeah, really look at it. Yeah. Just off the top of your head, real quick.
It gets a lot. It gets fairly confused when you're bringing in the zodiac stuff. Yeah, because it's sort of been a bit garbled, and especially a lot of the problems I see with the zodiac is um, the way our calendar system works. So if we had the proper calendar, then maybe the zodiac would start to uh, correspond to what the older people were saying.
Absolutely. So what do you think about this picture? You've showed me pictures that look kind of like this. Are you able to see it? Am I sharing it?
Yeah, I can see it.
Do I need to zoom in a little bit?
Yeah, zoom in a bit if you can.
We'll just start at the top.
It's sort of looking like how I've described a few things as well, with that gradients of matter as well. Those solids down the bottom, then you move up and up into more energetic realms. And yeah, it's interesting, the celestial fire and things like that. And again, when you're looking at those two salt elements, the sodium and potassium, well, they're directly correlated to the galvanic cell. The potassium nitrates are in the salt bridge, and then the sodium's in the electrolyte. So the salt bridge corresponds to the earth, and then the electrolyte corresponds to the oceans. And yeah, you got those two different salts.
Yeah, and the water, the fission, it just breaks everything down and helps it rise. It returns to the source and then gets brought right back down.
Yeah, and the sort of more you get into this stuff, you see that it's it's just cycling on itself, and it, in a sense, it's eternal that way, because these elements are getting and it brings back the ideas of transmutation of elements. So these elements are constantly transmuting and cycling, but they're not, and in a sense, it's eternal. They just keep cycling. They don't. That nothing goes away, or
yeah, that's one of the laws of hermetics. Hermetic alchemy.
Yeah, and it's a nice way of viewing our world and some of the elements in it. They just transmutate, change into different things, and then, but all in all, it doesn't, disappear, or doesn't float off into space or something like that.
This is just rainwater here. And alchemists had classifications like this for just the rainwater.
I've spoken to Benjamin Balderson, who does the same thing, and he has done some of that, the alchemy on water, and he will get those different. So it's really interesting talking to him about, how he views the processes that he's doing. And a lot of it he learns by actually doing the operations, the alchemical operations himself. But there are other alchemists that have talking about this, separating the waters into different sort of components.
And then you can build with them. In this book, it talks about some crazy stuff that alchemists have claimed to do in the past, and one of them is taking rainwater and being able to create an animal life form out of it, a mineral life form out of it, and a plant life form out of it with just the rainwater.
That would not surprise me at all, especially since nearly all the old mythologies talk about, the waters of life, basically. So, all contained
everything,
within the water itself. Yeah,
everything here is created by the rainwaters, and it's just the recycled matter. It's the matter being recycled. They call it, nuclear fission. They say an electron goes flying off and it changes the element then. And it loses, an electron every however long it takes. But it's fission. It's breaking it down, changing it. And as all this stuff is breaking down, that one electron or your hydrogen atom is going to go flying up to the top. it's gonna, it's got to get up there back to the source, and then it gets recycled back down into us.
Yeah, and speaking of hydrogen, like, I basically, have a bit of a theory going, and you can throw it out, but there's basically sulfur contained in hydrogen. So sulfur, hydrogen is a refined sulfur in a sense, and that's why you get that sort of burning yellow. Again, when you start seeing elements that have the same sort of colors and things like that, you recognize the colors, and then you can make these associations. So it helps to view it in that fashion as well, to try and just add a different perspective on how you're researching, and that's all we're trying to do, basically, trying to draw out information that may correspond and give us an understanding, really.
I thought this was neat right here. When thou made the quadrangle round, then is all the secret found. Ripley, 1480. It almost looks like a Fibonacci sequence, doesn't it?
The spiral. Yep.
Yeah. The golden chain of Homer. Yeah, I just wanted to show, and it gets into the Sephiroth.
Yeah, and some of these older, mythologies, again, I was talking to Ben, and he said, some of them are actually alchemical processes, sort of within a storyline. So they're actually talking about some of this stuff. But those mythologies are really sometimes difficult to understand, but there's definitely information encoded with them. It's
much info. It was meant to be like that. Alchemy was not practiced by common people. It was a hidden thing. I mean, to where they went around and destroyed all alchemy shops. And, if you were trying to make gold out of other metals, a pope and a king both made this act illegal. Now, how many things that are impossible do they make a law to make it illegal?
Yeah, well, it's they could have been trying to blot out the old science too.
Yeah, I think that's what they were doing. They didn't want people to know about this. Most alchemy back in the day was just practiced by priests, the high priest too. It wasn't at least in this book, this is how he explains it. Again, it's history. It's his story.
Yeah, that's right. But you would have needed a bit of funding to be able to do any sort of
any sort of alchemy. I mean, you had to keep fires going for, somebody would have to tend your fires for you and keep them going for days and months, at a time.
Yeah, well, that's based on the history we're sort of being given to. So,
Yeah.
It's like
I just wanted to get down here to the end and show, I'm looking at a couple of the pictures, but just some of the books that he, went to get his information. There you go. Secrets of the Adept, 1685, 1678, 1723, 1922. He went back and grabbed, some of the older stuff and pulled 1723 edition.
Yeah. A lot of it corresponds to Hermes, which is Mercury as well. So Mercury is actually associated, with those 7 hermetic principles, the principle of vibration, polarity, and all that sort of stuff. But it's also related to the 7 liberal arts, which is your arithmetic and geometry, astrology. So that it relates back to this whole world of old science. So that's why there's these this Hermes figure or Mercury figure always shows up in the alchemical stuff, which is basically chemistry.
Mm-hmm.
Well,
Chemistry with the spirituality removed from it.
yeah, exactly.
Yeah, they took away all the intent and all that kind of stuff and made it to where anybody mixes these chemicals, it's going to work in this way. You know, they took out the whole, I'm going to put this intent into it, and our real power that we have, this real.
Well, I think they took away the ability to correspond it to the natural world in a lot of ways. Yeah, they just have it dry and, you know, do it in your little beaker instead of, you know, correlating it to what's happening in the outside world.
Yeah, the head of the Alchemical Institute back in the day, he talks about it in this book, strongly opposed removing, you know, the spirituality out of alchemy, the astrology out of alchemy, you know, because that also had a lot to do with it. When you plant your seeds, when you harvest, all these things, you know, and they removed all of that from the making of the medicines.
Well, that's part of the globe lie, isn't it? Really, it goes part and parcel with that same thing of removing people from the natural world and reality. So whenever we go back into these sort of older ideas, we're going to get a sort of a wider viewpoint, and that's what we, you know, hope to gain.
Yeah, absolutely. Well, you want to open up the phone a little bit, see if anybody has anything to add to our conversation? All righty. Let me drop the link in chat. There you go, folks. If anybody'd like to jump in, just say hi, even, whatever, talk about some of the stuff you saw. I've been thinking about that water falling and how it would apply to rain. I think it's 170 maybe lightning strikes per second, they say, and maybe 80. I forget. I don't want to say. It's a lot of lightning every day, every second. So there's a lot of electrical discharging going on between the, you know, above and below. Now, not all these strikes are hitting, you know, are turning into sprites. A lot of it's just between the clouds and the ground.
Yep.
But yeah, they're happening. So there's a lot of electricity being transferred through the air at all times. It's
well, you're going to get these, you know, electricity build up just by having the high and low pressures as well. So hot days and cool days and that sort of thing. So that differential is going to create a differential in charge.
Yeah, absolutely.
I wonder what the electricity is doing to the water as well. You know, is it doing something interesting to the water? And like they say, you know, well, I know for myself, if you get a good bit of rain on your garden, well, it's going to grow like buggery compared to if you put it out of the pipe for town water. It's nowhere near the same quality.
No, I used to collect rainwater and I'd go around pouring it on every plant until I ran out of it before I would turn on a hose and use a sprinkler.
Oh yeah.
Real quick.
Go.
I just wanted to say, everybody, Dr. La 0206, great gentleman. Met him a few times, gives great hugs, loves cooking for people. He just has a lot of passion, he's in this for the right reasons. Well, his brother is sick in the hospital right now in ICU. And if you got, you know, a couple seconds extra to just say a prayer, send some love to La and his family, I know he'll appreciate it. So, La, I love you, brother. Hope you're doing all right. And that's it. I heard about this yesterday, and it's rough. It all has to do with the COVIDiocy that's going on right now. And, you know, I don't even want to talk about it. I'm not even going to say anything about it because it just get me mad. But yeah, send some love to La. if you got a little extra to send. He could use it. Well, I don't know if anybody's going to want to join us. No worries. Yeah,
No worries.
we got about an hour in there. Shared a couple cool things, I think. I've been busy this week, folks. I'm sorry. I meant to have a few more things planned, but I had a couple hats ordered, and I went and did some work today, putting in a new stovetop for a lady, fellow flat earther. It was awesome. But I just didn't have as much time to get all this stuff. I've had other stuff going on, but I'm going to be going through Walter Lewin's videos, and just pulling out some of the really cool experiments to where he shows how it applies to nature in a way. And, maybe you can be one of the people who figures out that part of the puzzle, because it's a big puzzle and we need a lot of people to help put this thing together.
Oh yeah, definitely. I mean, the more people that look at this stuff, sort of, do their own research and come up with their own ideas, and delve into different books and things like that, it all helps. It's the more people, the faster it's going to be to getting a coherent sort of understanding of what's happening, and that's progression.
Yeah, that's all we're trying to do. We could really use, some electric field measurements. I talked to Dwayne Kellum about it, sent him a few messages. He's looking into it. I can't think of how to do it. Not easily, not without having big, long pieces of wire connected to things going way up in the air.
And you need to look at like different materials as well, and what they're doing.
Well, there's quite a few patents out there, but they're not made for measuring. They're made for gathering electricity. Back in, the 1910 to 1930, there were quite a few people that were like mimicking Tesla's ideas. And instead of having a big giant tower, they were trying to put balloons up there with all these different metal objects around it and stuff. So it's been out there for a while, this idea. But I'd rather just measure it as high as I can go and start from there.
The other thing, like, especially when I sort of think about that Tesla's tower, I think he's doing stuff underground as well, because I see the Earth as like a capacitor, as well as the salt bridge is the capacitor in the galvanic model as well. And I also see it as a galvanic pile. So you guys can look up what a galvanic pile is. But I think he's doing stuff underground. He could be doing stuff with water. But it would be interesting to have measurements of can you get a higher differential in charge when you have, say, a metal pole going down into the ground, and then a tower on top of that to get a different, a larger charge. You know what I'm saying?
Yeah, absolutely.
Yeah.
Oh yeah, that's what a lot of the different, as you go through the patents, you start seeing these different things like, wow, this guy used this metal, this guy used this. They put them at different, separations so they aren't discharging up there. And
yeah. So yeah, it's similar to creating an Earth battery, but you're getting a potential difference from having something in the air. So, and you're tapping into it that way. And you could be into a water source down below as well. That there could be some underground water or underground salt water aquifer or something like that. And just like you showed with the separation of water and that video and that charge being built up, there could be something occurring. They might have a better understanding of how you actually draw down the energy from above.
Yeah. If there's water. Oh, sorry. Go ahead.
I think that's mainly when we look at sort of these old mud flood buildings and they have like a aerial on top of them or something like that. It's not necessarily that they're just you're going to collect small amounts, but how you're going to draw that energy down is probably the most critical component of it. And where you're going to
store it.
Yeah, well, you can draw it down, but then it's just how much you're going to draw down, because you can have a wire sticking in the air, it might not do anything. But if you start connecting it down into the earth and something, there might be a huge amount of difference to what happens then. But since
if there's underground running water producing all this positive electricity in that area, the ground's going to gather more negative charge right around there to equal it out.
Yeah, so that's right. It's not necessarily so much as having to store it, because you may not need to store it if you can increase the potential difference between
higher.
Yeah, so you and you may not even need to get that high up into the air. I mean, some of these are obviously, but it's so that there's just some other things to think about, that there's maybe stuff happening underneath that's just as critical as having a wire sticking up out of the ground.
Yeah, I've heard of people getting in trouble over here for going along the big, tall power lines. Not the ones right on the side of the road, but the ones that are in the middle of the fields, that, the big ones. And they'll plant a long cable underneath there, a long wire, big, thick wire, and just grab the power right off those things.
Yeah, I've heard the same. Yeah, where they're basically inducing it into the...
Yeah,
creating induction. I mean, it's good.
So there's so much about electricity that, needs to be comprehended by more people. And then we can start bitching about it. Why aren't we applying this? Why am I paying so much for electricity when this shit should be free?
Wow, that's all it comes back to. And that's what got me going in before even I was looking at this, stumbled across the galvanic cell sort of stuff. I was more interested in free energy. I'm like, how do I get out of this rat race? I want a free energy device.
Absolutely.
So just go to some little, pokey spot out in the middle of the bush and just plug in.
Yeah. Have all the comforts of home right there.
Yeah, exactly.
Yeah. Well, that's what they don't want.
Yeah, exactly. That's what they don't want, because it's in the name. It's where they get their power from, you plugging into their system. And any way we can sort of remove ourselves from that, and if you know how to do it, and you go, well, I want to just go and live over here out of the way of everyone and plug in and have as much energy as I need to live, they don't like that.
No.
They want you all in a big city,
somewhere they can keep you, all in contained, one nice area. You're a lot easier to watch that way.
Yeah, exactly. Yeah. They don't want everyone, setting up a greenhouse and having it fully functional and, heated and cooled and, perfect temperature all year round, so you can produce, thousands of pounds of food for yourself, with pretty much no effort.
No, we can't have that. That's insanity.
Not allowed.
Well, all right, folks. I guess we're going to call it. Thank you so much for coming and hanging out with us. I hope we showed you something you might not have seen before, or at the very least, reinvigorated that thinking that you were doing. Let's put some brain power towards electricity and nature, and just the things we can test and play with, and see if we can't recreate some of these things and manipulate them, and that's how we learn.
And if you find any interesting stuff, just send it to me or Zach.
Absolutely.
I'm happy to communicate, and
if you find something cool, if you find something cool and you'd like us to cover it and you want to share it with us, please don't hesitate. I learned one thing from Martin Liedtke. I've sent Martin Liedtke 10, 15 different things, And on 14 out of the 15, he was like, oh, yeah, I saw that. I covered that 2 years ago. Oh, yeah, I saw that, you know? But that one time, and it wasn't the first time. It was like one of the last times, actually. He was like, no way. That's awesome. And then he went and did a show on it and covered it. So, yeah, just because we've done some research on this stuff, we definitely haven't covered it all.
No, it all helps, and yeah, if the more we can accumulate, the better it is.
Absolutely. Well, all right, folks, we're going to get out of here. Thank you so much for joining us. This was LCKing and Good Times for All, or Lucas and Zach. We'll be back again next weekend. Can you make it, Lucas, you think?
Yeah.
Awesome. All right. I am going to end it again how I started, because this is one of those videos it's a short clip, 1 minute long. Don't run off just yet. But it's Walter Lewin, great teacher, former MIT physics professor of 4 decades, explaining to his class for the first time what electricity is. And I'm going to if you're going to be here, you're going to know this by the end, by the time we're done talking about electricity, you're going to have this memorized. So here we go, one more time.
Electricity and magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, televisions, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that.
If you only know the name, you know nothing. So Good Times for All here signing out. As always, thanks for watching.